So hello everyone. So today's class is going to be on second week development, a very important week that you need to understand lots of terminologies, how it happens. So last class where we stopped, so I just wanted to give you just a minute recap on what we saw in the previous session. So the embryology is going to be a continuous one. So yes, we saw about the fertilization and implantation events. So we saw yes at the third day, starting with fertilization. Okay. So within 12 to 24 hours, yes, after ovulation, the oocyte has to be fertilized by the sperm, right? So the zygote is formed. So that zygote will undergo cleavage, and about third day, yes, you have got the morula formation. Then we have advanced morula stage that is formed on the fourth day, that gets into the uterus. So when it gets into the uterus, the uterine fluid is going to enter into the morula stage and it is going to form a cavity, yes, that is called blastocele. So as a result, I get two layers, an outer cell mass and an inner cell mass. Outer cell mass is called as the trophoblast, inner cell mass is called as the embryoblast, right? And this trophoblast is going to help in the implantation. Yes, so if you take as this is the implanted embryo. Now what you have to know is, before we start off with the second week of development, this implantation initially is very weak, right? So if you take as it is just got a minimum adherence, right? So it is really weak. So as day progresses, the strength of implantation is going to be more, right? Yes. So with that, let us get into the second week development. So about 5.5 to 6 to 7 days, yes, the fertilization and the first week development is done. So now second week development. So what happens after this feeble implantation on the day 8? Yes, can you make out from this picture? What happens is, so these two layers, this green color, this is the trophoblast. Yes, this is your trophoblast, and this blue and yellow one is your inner cell mass. So in day 8, there is some change that is happening in the trophoblastic cells and the inner cell mass, or the embryoblastic cells. So what happens in the trophoblastic cells? Yes, can you make out two parts? Is this light color green one is called as the cytotrophoblast, and this irregular dark green portion is called as the syncytiotrophoblast. So what happens? The trophoblast, it divides into two layers of cells. One is called as the cytotrophoblast, which is uninucleate. So can you make out all the cells have got a single nucleus and they have got a regular margin, right? They are almost a cuboidal like cell, right? So they have got some regular margins, that is called as the cytotrophoblast, and you have got an irregular cells that is called as the syncytiotrophoblast, as it is called as your syncytiotrophoblast. Now this syncytiotrophoblast is the one that is going to secrete the SCG. So when we talk about the endocrinology in the further classes, we'll be talking about the role of syncytiotrophoblast. Just now understand the trophoblastic cells is divided into two, that is the syncytiotrophoblast and the cytotrophoblast. Similarly, if you take, yes, the inner cell mass is divided into two, the epiblast and the hypoblast. Yes, the epiblast and the hypoblast. So just know these four terminologies. Yes, epiblast, hypoblast, syncytiotrophoblast, and cytotrophoblast. So if we can now give a very small diagram, I saw in one of the Google images. So what he has done is, now first I am going to depict the inner cell mass here. Now the inner cell mass, it divides into two group of cells. Yes, can you make out a blue color one and a yellow color one? Yes, the blue color one is called as the epiblast. So what happens is, the inner cell mass on the top, it is going to get differentiated into a columnar cells. Yes, it is differentiated into a columnar cells. These cells are called as epiblast. This name is very familiar to us. Yes, if you remember my first class from gametogenesis, we saw the primordial germ cells were developed from the epiblast at around the second week. Yes, so if you take, yes, the inner cell mass is going to divide into highly columnar cells called as your epiblast. And similarly, you take below that, you have got, yes, below that you have got a layer of cuboidal cells. Yes, you have got a cuboidal cells. This is called as hypoblast. Yes, this is called as hypoblast. Now, each of them is going to give rise to a cavity. Yes, each of them is going to give rise to a cavity. The cavity which is enclosed by the epiblastic cell layer, as it is called as amniotic cavity. As it is called as amniotic cavity. The cavity that is enclosed by the hypoblast, as it is referred to as primitive yolk sac. So we'll be seeing in the day 9. So this primitive yolk sac will develop in the day 9, but yes, these cells are going to enclose the future cavities like your primary yolk sac and the amniotic cavity. Yes, now surrounding this you have got certain layers. So this is the inner cell mass derivatives, right? So outer cell, if you take, yes, you have got a cytotrophoblast, which is very regular in margins, and you have got a syncytiotrophoblast. Yes, you have got a syncytiotrophoblast, right? So if you take, this is what happens in the day 8, right? So differentiation of trophoblastic into syncytiotrophoblas and the cytotrophoblast, wherein syncytiotrophoblast is going to be irregular in margin, and syncytium means what? It is made up of many nuclei, right? So syncytiotrophoblast is made up of many nuclei. It has got an irregular margin, as the cytotrophoblast is well differentiated. I mean, it has got a single nuclei and it has got a definitive margin. The inner cell mass, it is divided into two groups as the epiblast and the hypoblast. The epiblast layer is going to give rise to a cavity or enclose a cavity called amniotic cavity. Right, amniotic cavity, which in turn is going to be filled with the amniotic fluid, and the hypoblast layer will give rise to primitive yolk sac that happens in the day 9. Right, so this is the understanding that you must have. So the second week development is going to revolve only around these terminologies. Yes, I hope you are clear with day 8. Now, coming to day 9. Yes, can you make out what happens is this structure that we have seen in the day 8, it is going to grow, right? It is going to extensively grow, and you get some structures like this. Yes, can you make out this blue color columnar cells? These are epiblast, and they are enclosing a cavity called as amniotic cavity. And this is the light green color one, as this is your cytotrophoblast, and this dark green color one is the syncytiotrophoblast. And can you make out there is a cavity here, as this cavity is called as your primitive yolk sac. We'll come to that now. So first let us talk about the outer cell, that is the trophoblast. Now, can you make a difference here? On the day 8, as the size of the embryo was very small, and the syncytiotrophoblast was also it was distributed in a very small region, right? Now, can you make out it has extensively grown and it is made up of so many spaces? Yes, so what happens in day 9 is, the very first thing that you must know with respect to day 9 is the lacunar stage. So what happens is, as the cells grow in size, the syncytiotrophoblast is going to form so many vesicles or vacuoles, I can say. Yes, they are going to form so many vacuoles or the empty spaces. So all these vacuoles, say suppose you have got a vacuole here. Yes, this is a vacuole. So you have got so many vacuoles. All these vacuoles will fuse together to form something called as lacunae. Yes, to form something called lacunae. Right, so the first thing that happens in day 9 is it's the lacunar stage, wherein the trophoblast, that is the syncytiotrophoblast, is going to show some lacunae. I'll tell you what is the role of lacunae in day 11 and day 12, right? So just now you understand, yes, there is formation of lacuna. And similarly, as I told you in the last slide, as the hypoblastic layer will start giving rise to primitive yolk sac that is very visible on the 9th day. So what happens is, the hypoblastic layer, it is going to give rise to a certain flattened epithelial cells. Can you make out these small cells here? It is going to give rise to a flattened epithelial cell layer, and it thus forms a cavity, and that cavity is called as primitive yolk sac. Yes, this primitive yolk sac is also referred to as 𝑥𝐸lomic cavity or exocelomic cavity. Yes. So the second important thing that happens in day 9 is the formation of primitive yolk sac or exocelomic cavity. So they can ask you in your exams as the two important features of day 9 development. One is the lacunar stage, where the trophoblast is going to present with lacunae. The second one is the formation of exocelomic cavity or the primitive yolk sac. Now, if you take, these are the derivatives of inner cell mass, and this one is your trophoblastic layer, right? So if you take This cytotrophoblast and this primitive yolk sac is separated by a membrane called as exocelomic membrane. Yes, this yellow color one here is the exocelomic membrane, which separates the exocelomic cavity from your cytotrophoblast. Yes, it separates the exocelomic cavity from your cytotrophoblast. Yes, it is called as the exocelomic or the user's membrane. Right? So this is what happens in day 9. I hope you are clear with day 9. Now day 11, 12, 13 are important. Please pay attention. Yes. So what we will do is, I will try to draw the picture. So this is the inner cell mass derivatives. This is my cytotrophoblast. And this is my syncytiotrophoblast. And this syncytiotrophoblast, now it has got so many lacunae here. Right? So let us quickly name the parts so that it will be a revision for you. Yes, this is my, let me draw some cells for you. Yes. So this is epiblast. And this one is my amniotic cavity. And sorry, this should be 𝑄𝗵𝗿𝗲. I'm sorry. This is my hypoblast. And yes, on the day 9, I've got the primitive yolk sac, or called as the exocelomic cavity. And this lining, let me use an highlighter. Maybe this color. Yes. So this layer, this is the user's membrane that separates the cytotrophoblast and the primitive yolk sac. It is joined. Yes, can you make out from this picture? It is very closely related, but I want to show you something here. That's why I have given some gap here, right? Do not worry. Now, what happens is, can you make out some orange color structures here? Yes, you'll be able to make out, right? Two things will happen. One is the formation of this some spaces with the orange color one. Another one, can you make out? Yes, the lacunae are all completely filled with red color one. Yes, what is that? Blood. So if you take out, what happens is, yes, this is my uterine cavity, the endometrial cavity, right? And it has got blood vessels. Yes, it has got blood vessels. Now, in the very beginning, I told you the implantation is very feeble, right? Initially, the implantation is very feeble. As the day progresses, the implantation is going to be stronger. So approximately from the 10th day and 11 and 12, the implantation is going to be stronger. So what happens is, the trophoblastic layer will try to establish a firm adherence with the endometrial cavity. So what happens that time? This trophoblastic layer of cells is going to go and erode all the endometrial capillaries. Yes, it is going to erode all the maternal capillaries. So it is going to begin with erosion of the maternal capillaries. So as a result, yes, all your capillaries are eroded. So what happens is, the capillaries that are present, it gets engorged and dilated. What happens is, it gets engorged and dilated. Such an engorged and dilated vessels are called as sinusoid. Yes, can you make out? It is engorged. It has become very irregular, engorged, and it is dilated. Yes, can you make out the difference? See here, it is very thin, right? The lumen is very thin, but because of the invasion, it has become very engorged and dilated. So these are called as sinusoids. Yes, these are called as sinusoids. So as a result of erosion of the maternal capillaries by the invading trophoblastic cell layer, there is formation of sinusoids. These sinusoids, they communicate with the trophoblastic lacunae. So now do you understand why in the day 9 a lacunae was formed? Yes, because the trophoblast is invading the endometrial cavity, and the god has very well predicted that yes, this will go and damage all the maternal capillaries. So that will form a sinusoid. Those sinusoids has to communicate with the embryo. So I have to establish lacunae. So God has created by predicting the future of the embryo, right? So yes, so what happens? All these sinusoids, it communicates with the trophoblastic lacunae. Yes, it communicates with the trophoblastic lacunae, thus establishing a very important question: uteroplacental circulation. Yes, it establishes uteroplacental circulation. So this can be your MCQ question at approximately which day Utero-placental circulation is established as it is approximately around day 11 and 12, where the sinusoids are going to communicate with the trophoblastic lacunae. So this is one set of events that happen. What is another set? As I told you, you have some orange color cells formed, right? So what happens is, yes, a very important thing, between the cytotrophoblast, yes, this is the cytotrophoblast, and this is the developing embryo. Here, what happens is there is formation of a layer of cells. So there are a group of cells that comes and it is going to fill the space between the cytotrophoblast and the developing embryo. As this one is a mesodermal derivative, hence I have got a name, extra-embryonic mesoderm. Yes, what is the name of these group of cells? Yes, it is extra-embryonic mesoderm. So what happens? In between the cytotrophoblast, and the embryo, there develops a group of cells called as extra-embryonic mesodermal cells. Yes, or to be more precise, I can say the cell is going to organize between the cytotrophoblast and the primitive yolk sac. Yes, it is going to develop between the cytotrophoblast and the primitive yolk sac. Right. So basically, in between the cytotrophoblast and the primitive yolk sac, there appears a group of cells called as extra-embryonic mesodermal cells. Now, what happens to these cells is, can you make out, initially it would have been like this, right? Fully without any space, without any vortices, without any spaces like this, the entire thing would have been covered by the mesodermal cells. Then what happens is there appears, then slowly cavity begins to appear. Is what happens? Slowly the vacuoles begin to appear and all that will combine to form a cavity which is called as extraembryonic cavity or the chorionic cavity. Yes, or called as chorionic cavity. Right? So now what happens? Yes, this extraembryonic cavity or chorionic cavity, it is going to be present almost everywhere. Yes, can you make out? This is the primitive yolk sac and this is the cytotrophoblast, and this cavity is going to be present almost everywhere, except, can you make out? Here I am not able to appreciate any cavity. Yes. Now what is this? Let me show you in this picture. Can you make out? Yes. Now this lateral side alone, it is filled with the mesodermal cells, right? So what is this called? As this is called the connecting stalk. This is called as the connecting stalk. So what happens is, simultaneously when the mesodermal cells are formed between the cytotrophoblast and the primitive yolk sac, a group of mesodermal cells forms a stalk-like structure. It is going to form the stalk-like structure that connects the amnion. Yes, this is the amniotic cavity. This is the cytotrophoblast. It is going to form a connecting stalk-like structure. So it begins to appear. It is not completely formed. It begins to appear. We will see what is the role of connecting stalk in the next day, because that is where it is very predominantly present, or that is where it is well established, right? So what are the things that you must know in day 11 and day 12? Is first is the utero-placental circulation. Second one is, what you have to know is there is a formation of an extra-embryonic mesodermal cavity. There is a formation of extra-embryonal mesodermal cells between the cytotrophoblast and the primitive yolk sac, and these cells are going to cover all along the primitive yolk sac and the amnion, except where the amnion establishes a connection with the cytotrophoblast. And there is a space that appears slowly in the mesodermal cells, and that gives rise to a cavity called as the extraembryonic cavity or the chorionic cavity. Yes, it gives rise to an extraembryonic cavity or a chorionic cavity. Now let us try to draw this and explain. I'll explain you certain terminologies. So if you can make out, he has given something called as extraembryonic somatic mesoderm. He has spoke about extraembryonic splanchnic mesoderm. So all this, if I'm going to explain you with this picture, it becomes a bit difficult. So what I will do is I'll try to explain you with the line diagram. Yes. So we are going to draw another embryo. So yes, what is this? You all will know now. So here I will be having, please do not mind my diagram, it will be very pathetic, right? It needs a life. So this is my epiblast. Yes, this is my epiblast. This is my amniotic cavity. This is my epiblast. and this is my hypoblast with a primitive yolk sac. Yes, with a primitive yolk sac. And surrounding it, I have got a cytotrophoblast. So I have got a cytotrophoblast. Very bad cytotrophoblast. And surrounding this cytotrophoblast is what I have got. Yes, I have got my syncytiotrophoblast. Now, we saw that initially in between the yolk sac and the cytotrophoblast is there appears the mesodermal cells, the extraembryonic mesoderm, right? And in this extraembryonic mesoderm, I need to replace the cytotrophoblast. Yes, we'll draw a neat cytotrophoblast now. Just stay with me. 5 more minutes I'll complete, right? This is the cytotrophoblast, which looks a bit decent, right? Now, what happens now is, yes, I told you there is a layer of mesoderm that is formed in between the cytotrophoblast and the primitive yolk sac, right? Now, what happened is there are some cavities that are formed, right? So just imagine, yes, cavities are formed. Now, when the cavities are formed, just imagine what happens. Yes, I'm going to draw this again. I'll just show you one side, okay, because it is becoming very difficult for me to draw 360 degree. Just imagine, as this is the mesoderm, which is surrounding, and there is a cavity that appears. So if I'm going to erase some part in the middle, yes, entire thing is gone. Say suppose there is a cavity that appeared here. Yes, so there are these cavities are called what? Yes, they are called as chorionic cavity. So when this cavity is formed, the mesodermal, now it appears as 2 layers. Can you appreciate a cavity is going to be between the mesoderm, so we get 2 extremes, right? Yes, can you make out from this picture? This is one portion of the mesoderm that is very closely associated with the cytotrophoblast, and this one is its layer of mesoderm that is very closely associated with the primitive yolk sac. Yes, primitive yolk sac. So the layer of mesoderm which lines the primitive yolk sac is called as the extraembryonic splanchnic mesoderm. Yes, what is the name? Extraembryonic splanchnic mesoderm. So this is the layer of mesoderm that lines the primitive yolk sac, right? This Users membrane is something that is going to separate the cytotrophoblast from the primitive yolk sac. That is a primitive structure, but which separates the chorionic cavity from the primitive yolk sac. Yes, this is the extraembryonic splanchnic mesoderm, right? So initially, that's why I gave this this rough picture, is because initially mesoderm was completely present, then there a cavity appeared, so we get 2 layers of mesoderm now. Yes, we get 2 layers of mesoderm like this. So this green color one, which is in close association with the primitive yolk sac, yes, it is called as the extraembryonic splanchnic mesoderm. Yes, it is called as the extraembryonic splanchnic mesoderm. And which is in close association with the cytotrophoblast, it is called as the extraembryonic somatic mesoderm. Yes, it is called as the extraembryonic somatic mesoderm. If you get to this picture, yes, this is the extraembryonic somatic mesoderm that is in close association with the cytotrophoblast, and this one is the extraembryonic splanchnic mesoderm that is going to line the primitive yolk sac. Yes, so what are the terminologies that you must know from here? Yes, uteroplacental circulation, very fast. Yes, uteroplacental circulation, then extraembryonic mesoderm, which in turn is going to be filled with a cavity called chorionic cavity. Yes, very good. And because of formation of chorionic cavity, this extraembryonic mesoderm is divided into 2 layers. S1, which is in close association with the primitive yolk sac, is called as the extraembryonic splanchnic mesoderm, and the other one, which is in close association with the cytotrophoblast, is called as the extraembryonic somatic mesoderm. Yes, very good. Right. So this is with respect to day 11 and day 12. Now, what happens in day 13? Yes, can you make out the chorionic cavity? Just see in day 11 and 12, yes, it appears as very small cavities, right? Now, what happens is cavity is continuously enlarging, and it forms a very big single chorionic cavity called as extraembryonic cavity. What is called as the 𝑥𝐶𝐿omic cavity that we saw in the 9th day? Yes, it was called as the primitive yolk sac, that was exocelomic cavity. Yes, which is the extra embryonic cavity. Yes, it is the chorionic cavity which is formed from the extra embryonic mesoderm. So what happens is it just expands very enormously and it forms a very big extra embryonic cavity, that is your chorionic cavity. So when this is forming, right, the cavity is expanding, right? Just look at this picture. It keeps expanding. So where it puts pressure? Yes, it puts pressure on the primitive yolk sac, that is your exocelomic cavity. Yes, it puts pressure on the exocelomic cavity. So what happens is the exocelomic cavity will start degenerating. It will reduce in size. Right? Can you make out exocelomic cyst? So this is basically the remnant or degenerated part of exocelomic cavity, right? And can you make out is this structure, which was like a ring, right, had become very small because of expanding cavity. So day 13, what happens is the chorionic cavity, it expands, and the second thing that happens is the primitive yolk sac that was initially present, now it is being converted to a secondary yolk sac. Right, it is again a change. So what happens is there is some degeneration of the exocelomic cavity, and again the 𝗵𝗶𝗴𝗀 is going to give rise to a new set of cavity cells. But this time the cavity, exocelomic cavity, is very small, and hence I call it as a secondary yolk sac. Now, in the day 11 and 12, when I was explaining you the extra embryonic mesoderm, I told you is the chorionic cavity forms at every aspect except where the amnion establishes a connection with the cytotrophoblast, and that I told as it gives rise to a structure called connecting stalk. So here the layer has begun to appear, and in the day 13, it forms a stalk. Right, this is called as a connecting stalk. And please note, very important, even for our PGs, this question can come. This connecting stalk gives rise to future umbilical cord. Yes, it gives rise to future umbilical cord. Right. So on day 13, as we have seen, expansion of chorionic cavity with the formation of connecting stalk, which gives rise to future umbilical cord. Then the primitive yolk sac, as the 𝗵𝗶𝗴𝗀 is going to give rise to a new set of cells. It forms a new cavity, but which is very smaller in size, as it is called as the secondary yolk sac. It is not actually a new cavity, but the existing primitive yolk sac, it reduces its size. That is what is called secondary yolk sac, right? Now, next important thing what you have to know is can you make out a new structure here is primary villi. So the villi will start appearing. You all know we have got so many villi, right? This primary villi will start appearing in the day 13. So it's a part of second week development. So what is this primary villi? So how a villi is formed? Now you all know this primary villi will later form secondary villi, tertiary villi. We'll see in the next videos. But primary villi is formed at this day 13 itself. So what is this primary villi is? Yes, can you make out what is this light green color structure? Yes, it is your cytotrophoblast. Now what happens is this cytotrophoblast is going to extend, right, as a finger-like projection, upwards throughout the layer of trophoblast. So what happens? Yes, it extends and its covering is made up of a syncytiotrophoblast. So the extension or the projection of the cytotrophoblast is the extension or the projection of the cytotrophoblast through the syncytiotrophoblast, where this projection externally is covered by the syncytiotrophoblast, is called as primary villi. Yes, it's called as primary villi. So this one, yes, this is your syncytiotrophoblast. Yes, this is your syncytiotrophoblast. This is your cytotrophoblast. Together it is called as my primary villi. Yes. So it is the extension of the cytotrophoblast along the syncytiotrophoblast layer, where the syncytiotrophoblast is covered by the cytotrophoblast, is called as the primary villi. So in the day 13, along with the secondary yolk sac, along with the chorionic cavity enlargement, yes, I get something along with these structures, primary villi. Right, along with this, I have primary villi. Right, so this is the second week development. So to summarize second week development, what all we saw is quickly in just another 3 minutes. Yes, it began with differentiation of the trophoblast into cytotrophoblast and syncytiotrophoblast. Then what happened? This side, then we had inner cell mass which developed into epiblast and hypoblast. Epiblast, as it gave rise to an amniotic cavity, and this hypoblast in the day 9 it gave rise to an 𝑥𝐸𝑎𝑙omic cavity that is called as your primitive yolk sac. Yes, along with that we had a lacunar stage in the day 9. I'll show you with the picture so it becomes simple, right? Along with that we saw a lacunar stage also, right? Yes, we saw lacunar stage. Then day 10, day 11, day 12 is that is where the implantation is going to become stronger. So this lacunar, so what happens is when it expands, the endometrial vessels are being eroded, so there is an engorgement dilatation, there's a formation of sinusoids. So those sinusoids are going to be continuous with the trophoblastic lacuna, hence forming a neuroplacental circulation, which happens in the day 11 and 12. At the same time, there is a formation of extra embryonic mesoderm. So slowly what happens is there is some cavity that is formed that is called as the chorionic cavity. It is formed all along the primitive yolk sac and the amnion, except where the amnion is going to communicate with the cytotrophoblast. Yes, what is the name of the communication called? Yes, it is called as the connecting stalk, which is well established in the day 13 that gives rise to future umbilical cord. Now this extra embryonic mesoderm, which gives rise to cavity, is there is going to be 2 layers of lining. Lining that is closely associated with the cytotrophoblast it is called as the extra embryonic somatic mesoderm, and the lining of the primitive yolk sac is the extra embryonic splanchnic mesoderm. It is called as extra embryonic splanchnic mesoderm. Then we saw about the day 13 where we spoke about the primary villi, and we saw the expansion of the chorionic cavity, which is going to degenerate some aspect of the 𝑥𝐸𝑎𝑙omic cavity, and there is a new 𝑥𝐸𝑎𝑙omic cavity formed which is reduced in size that is called secondary yolk sac, and there is formation of primary villi where the cytotrophoblast is going to project along this inside trophoblast, which is covered by this inside trophoblast, as it is called as the primary villi. Right. So this is with respect to second week development. Yes. So I hope you all understood. So we'll meet in the some other video next week. And I hope these sessions are useful. If you want any modifications or any suggestions, please kindly let us know. Right. Thank you. Take care. See you in some other video. Bye.